So yeah, there are my contact details if you need me later. And let's first go through some fundamentals of network analysis before we get to the hands-on part. Okay. So we are going to be working with graphs or networks. What is it? It is a data model that consists of nodes that can also be called vertices, and the connections between them that are called edges or links or arcs or just connections. You can encounter different terms. And networks provide a very clear and intuitive visual representation of relationships. So that's a data model to visualize relationships between individual entities, and these entities can be people, organizations, objects, anything, basically. And you can apply this model to different spheres, from say literary criticism, literary analysis, to chemistry. We will go through a few examples later. So graphs can be of different types. I will not go into much detail in graph theory and network theory, just the basic notions that you may encounter. So graphs can be either directed or undirected. So in a directed graph, edges have a direction. So the connection goes from one node to another, and you can just imagine these connections as arrows. In an undirected graph, connections don't have any direction, so you can just imagine them as lines and visualize them as lines. Then graphs can be connected or disconnected. In a connected graph, all nodes are a part of the main graph. All of them are connected to at least one. No, that's a bad word, bad definition. So all of the nodes are connected, and no node or a cluster of nodes is somewhere left astray. While in a disconnected graph, some nodes can be isolated from the main graph. Not necessarily just one node, there can be two nodes here, but if they're not connected to the main graph, it's still a disconnected graph, right? So the definition below is a bit better. So if in a disconnected graph, some vertices are unreachable, and in a connected graph, every vertex or every node can be reached through some kind of path or another from any other node. Then graphs can be weighted or unweighted. And in weighted graphs, connections have numerical values. So there are attributes that edges have that somehow characterize the connection, how important it is. And these numbers can represent different things, different metrics. And in an unweighted graph, all connections are equal. They don't have any numerical values. Then there are things called bipartite graphs, where you have two different sets of nodes, and every node from set A is connected to a node or nodes from the set B. So there is this bipartite relationship between these nodes. We're not going to work with this today, just so that you know what it is. Then graphs can be complete and incomplete. In the incomplete graph, every node is connected to every other node. So basically, they're very dense. There are a lot of connections. And an incomplete graph, obviously, not every node is connected to every other node. And a very important notion for today's work is a small world graph, because for social network analysis, these are the kind of graphs that you will very often encounter. So in small world graphs, each node has a few direct neighbors, but its neighbors are very likely to be connected to one another. And the fundamental property of such a graph is that any node can be reached in a very few steps from any other node. So we can think of the 6 handshakes theory. So like we all know each other, every person in the world in 6 handshakes. So that's what is behind that kind of graph. So a node doesn't necessarily have many connections itself, but a path from this node to any other node is quite short. And here it is in the center, in between a regular graph, just with a high clustering coefficient and long path length, and a random graph where all the connections are random. Okay, so where do we encounter graphs or networks in real life? For example, you can think of the metro map. I know it's not very relevant to Ireland, unfortunately, but here's the metro map or underground map of the London Tube. And in this map, stations can be viewed as nodes, while the tracks connecting them are edges or links. And if you're calculating the travel time, there are like apps for that. If you're calculating the time that it takes you to reach from one station to another, basically you're working with a weighted graph where each edge has a value of minutes that it takes to travel from one station to another. You can think of other transport networks in the same way. And then the picture on the right is a map of the internet. It's a pretty old one, probably it's much bigger now. And this is what it looks like, represented as a graph of IP addresses. So everything on the web has an IP address, so that's a unique address. And these IP addresses are clustered together, connected together, right? And this is what the whole picture looks like. Now, I already said social network analysis, or SNA. Sometimes it's simply called network analysis, or NA, and it is a research method that is used to understand and to visualize how networks function, and how do we identify the most important nodes in them, and how do we identify important communities in them. I will talk about communities in a minute. So it involves analyzing the connections as well as the characteristics of individual nodes. So this is just the picture from some company website that gives you an example how it can be applied to some business research. What organizations are connected together, how they interact, and so on. Communities are dense subgraphs where all or almost nodes are interconnected, and it's very important for social network analysis because this way, in one way or another, especially in small world graphs, nodes are organized into communities. This is just on the left how it looks like as an abstract model, and on the right is a more real world example. Say if you want to visualize a network of your friends on social media, they will most likely cluster or organize into communities of your family, high school friends, college friends, friends you're connected with through a hobby, online friends, and some of these groups may have connections as well. Say, for example, if you went to college with the same people that you went to school with. Okay. Now, another thing, as I said, it is important to understand communities, and it is important to understand how important a node is. There are various metrics to do that, and a metric is a way to measure something, a standardized way to measure something, right? So in graph theory and in social network analysis by extension, we have a degree, and a degree simply means the number of connections the node has. And then we have a weighted degree, a number of connections of a node that is divided by the total number of connections in the graph. So these are the two important ones. And then how do we measure the importance of the node? We can work with the degree, simply with the number of connections. It's the easiest way. So the more connections a node has, the more important it is. And in the picture on the left, you can see this in the top left corner. So the red nodes are the most important ones, and the cooler it gets, the less important the nodes are. So if we use degree centrality as the measure of importance, so the number of connections a node has, the most important nodes will be those that have most connections. And these are the red in the picture in the top left corner. But that's not always very representative of a structure of a network we're analyzing. Sometimes it can be more important which nodes are the most central. So not the nodes that have most connections, but what nodes connect different communities, different sections of the graph. So we have closest centrality. It is about the central part or centrality of a node in the graph. So if it is very close to every other node, then it is the most important, and that's the picture in the top right corner. So literally, these nodes are literally in the center. You can reach every other node from them very quickly in a very few steps. And then, as I said before, sometimes it is important which nodes connect different parts of the graph. And we can measure that with betweenness centrality. So according to this metric, the more often a node connects to other nodes, the more important it is. And that's the picture in the bottom left corner. So the red nodes or orange nodes connect two sections of the graph, and they are the most important. And finally, it's not the last, but the fourth of the most popular metrics to define the importance of the node is eigencentrality, which states the more friends you have, the more important you, the more friends your friends have, the more important you are. So it doesn't matter how many connections you have yourself, unlike degree centrality. If you have very few connections, but your connections have very large networks themselves, then you are important. So you can have very few but very important friends, and that's eigencentrality. And that's the bottom right picture. Okay. There are a few other notions that might come in handy. We'll just discuss modularity here because we're going to be using it to work with our graph today. So modularity measures how much denser the connections within a group or community are compared to the connections between different groups. And this is a metric that helps to define communities, to split the graph into different chunks. And we're going to be doing this today. The first three, they're important, but we're not going to touch them directly today. So now we'll be moving slowly to the practical part. We're not going to discuss how to create a graph from raw data today, because it most likely will involve some programming skills, and that's not a part of this workshop series. So we'll be assuming that we already have some data in the graph format. There are different graph formats. They can be either text-based, like GML or CSV, or XML based like GraphML, GXF. There are quite a few others, but these are, I think, the most popular ones. And you have just two screenshots how the data looks like in an XML-based GXF format. You have a list of nodes, you have a list of edges, and in every node, within every node, and within every edge, you can have attributes. So it's structured like the same way as, say, HTML, very similar, right? And I have CSV here, which is a simple table format where every column is separated by a comma. You have source, target, type, weight. You can have as many columns as you like, as many attributes as you like, and you can import this kind of data to Gephi as well. Okay, now Gephi is an open source free software for visualizing networks. You have the download link here, but I assume you already downloaded and installed it. They are a bit strange with their numbering. Yes, the most current version is 0.10. It's not very different from previous versions. Like, say 5-7 years ago, it was 0.9. And I say not much has changed except for the number of available algorithms and just the fixing of some bugs. So if you have an older version, this tutorial will still be useful to you. And of course, they have a user guide and they have a page with tutorials, both by the authors and by the members of community. And I sent you all a link to GitHub repository where you'll have these slides, where you'll have the lecture notes, so you have all the links to explore later. And on the right is just a picture from a DH, during DH conference from 2016. And these are the, if I remember correctly now, the English novels by Jan Rybicki. Anyway, there is a link there to the abstract, so you can have a look. And now we're going to example. That's another graph from the same work, so you can see it's pretty old. And that's a chronology of Charles Dickens novels by Jan Rybicki, and it's built using most frequent words in the text. So that's one of the applications for literary studies called stilometry, where you compare how similar the texts are, if they belong to the same author, if they belong to the same period in the author's artistic life, by comparing the words. So he visualized these novels by Charles Dickens, comparing the words used in them. It's one example. So another example is a network of thematic connections in artworks from the Smithsonian American Art Museum, made in a particular time period by Matthew Lincoln, his own website. So here he used the metadata available on the digital collections of the museum and drew connections between items that have basically the same keywords in their description. So this is about, I don't know, boats or something else. So this is a bit probably too small to see now, but you can go to follow the link in the slides and see it in more detail. I think he also has an interactive version of this. Another example, an air transportation network based on open data from openflights.org that you can download as a graph file, by the way. And nodes here represent airports, node sizes reflect the number of routes, and colors roughly represent continents. They're colored by latitude, by Dr. Martin Grandjean, who also has great tutorials on social network analysis that I link to in the further reading section. So I very much recommend his website. So these are just a few applications. Oh, I actually have one more. That's a screenshot of an interactive graph of made based on the Ossian cycle of epic poems by James Macpherson. And you can see the relationships between characters there. It's positive, negative, or yeah. Oh yeah, and you can also group them by gender. Again, quite a different approach to study of literature. So even within the same field, you can find quite a lot of applications of this research method. Anyway, the data sources. As I said, we're not going to discuss how to create graphs ourselves, but there's quite a lot of interesting graph data available in different repositories and on the websites, and I linked a few of them here. And the workshop materials, that's the same link I sent you in the email, are all in the repository. For the hands-on section, we'll be using the data set of the Game of Thrones books, of character interactions from the Game of Thrones books. That originated from Kaggle. Kaggle is a machine learning competition platform, and it has a lot of great data sets. So what is a character interaction network? You can measure it in different ways, but most often you just go through a text with a slide-in window and see, say, 5 words or 10 words, and see if 2 different names occur in this window. And if they are, you record it as an interaction. When people analyze drama, they can do it differently. For example, they can draw a connection between people who are characters who are on stage at the same time. But for prose text, it's basically just a slide-in window and trying to see which character names are close to each other. Okay, now we're going to the hands-on session with Gephi. I hope all of you or most of you have it installed. So I'll stop showing these slides and I'll just launch Gephi. Oops. Okay, I'm still sharing. Yeah, great. Yeah, I'm sorry to the people online. I'm just the only person in the room, so I might be a bit slow to answer questions in the chat. I'll do that now. So it looks similar to the graph theory in mathematics. Yes, that's what it is based on. So all the concepts are borrowed from the graph theory. So if you know graph theory in mathematics, you're grand. You already know everything. Could you give perhaps an example of research questions that would be addressed by these methods of analysis? For example, you want to study citations, which scholars cite each other. Does it have anything to do with their affiliations? Does it have to do anything with their geographic relation? Or is it simply does it have to do anything with how many times they're cited, how popular they are in an academic community? Or does it simply have to do with the topic? So you can use something, you can build a network of citations and see which factors contribute to the importance of a particular author or a particular publication, something like that. Or I don't know if someone else has any examples of how you can use it in your own field of study, maybe? Meta-analysis. Mm-hmm. Yeah, cool. Yeah. Anything else? I have another example for you. Say in medieval studies, people study how manuscripts are copied, how texts are transmitted. So you can create a network of manuscripts based on, for example, text that you can find in like same text you can find in different manuscripts. So for example, you draw a link between two manuscripts if they contain the same text. Or you draw a link between manuscripts if you think one of a directed link, right, as an arrow, if you think one manuscript borrowed or copied the text from another, something like that. So you can study text transmission in that way. But yeah, I'm not a biologist or scientist in that way. So, but I know there are a lot of applications in physics and chemistry and biology of these things. Okay. Oh, another question. I'm thinking of a project to determine what kinds of training and which social professional networks lead dramaturgs to jobs. Yeah, this will definitely be a good application for that. Yeah, great example. Okay, so now let's just start with the hands-on part. First of all, let me show you where to download the data. Don't have a mouse here, which doesn't help. Drag my... Okay, here we go. Okay, so that's the link that I sent you. Link to the repository. You have a data folder here. There are a few data sets. If you prefer classical literature, there is a graph of Victor Hugo Les Miserables in two different formats. It's the same graph. So if you prefer that to the Game of Thrones, you can work with this. And then these are the Game of Thrones data separated by books. You can download any of the books. You can download all of them. It's enough just to work with one file. Combining them all will be just a little extra task. So any book you like. To download this, you can just click here and click download raw file. Okay? This should be pretty straightforward. All right. Yeah, and you'll get your normal download dialog window. Anyway, now let's start Gephi. Have to drag it again. Come on. Okay, and also this. So when you open Gephi, you have this startup window. Just give me a second. I'll open my lecture notes on another screen. Just not to forget anything. Okay, so yeah, that's the startup window, and you can either use one of the samples. They also love Hugo, so they have him here, or US airports, so Power Grid. You can open your recent projects, recent files, but when you're just starting working with it, you just need the button Open Graph File. And okay, two screens are annoying. Have to drag every pop-up window. So you get this, and you can open any of the CSV file or the GFX or any file you have. Yeah, by the way, if someone brought their own data, please feel free to work with it. That's great. Anyway, just select your file and click open. And when you do, you'll see this window. It will be different based on the format you're opening. In case of CSV, you can choose a separator. It's detected automatically, but in case there is a mistake, you can change it. So it's separated by comma. It is an age table. Yeah, it tells us the source and the target, right? So it tells us about the connections, and the nodes can be inferred from these connections. And the character set is UTF-8. It's safe to have this as your default encoding because it supports most of different alphabets. If you're working with data in a different language, then you click next. Don't have to change anything here, and finish. Once the import is finished, you will see this little report with the number of nodes, the number of edges between them, and some properties. Is it a dynamic graph? Is it like we're not going to work with this today, so these are not important for us. The important is the number of nodes, the number of edges, and if it is a directed or undirected graph. So if the links have directions or if they don't. And then you can add it to a new workspace or append to an existing workspace. We'll return to append to an existing workspace later, but now we just need a new workspace. That's our only option when starting a new project, okay? So when you just open your graph, it looks something like this. I don't know why it is so small. It shouldn't be. It should be this whole area, but okay. Really see my screen there. Anyway, sometimes the data you import will need some modifications, and we'd rather do them straight away, just because I know that this data needs that, than later when we're halfway through our project. A very important thing about Gephi is that it doesn't have an undo button. Don't ask me why. I don't know why they went with this design, but you can't undo your changes. You can save them, and I do advise to click Ctrl S once in a while and save it as a project before exporting. But there is no undo. So if you do something wrong, you'll have to redo everything. But luckily, it's not that hard, right? So the first thing we have to do here, just because that's the nature of the data, is to go from the Overview tab, which we get to when we open a project, to the Data Laboratory tab. And in this tab, you can manipulate the data, change it if you need. For example, add nodes and edges manually, add, delete, or merge columns, create new columns based on regular expressions. If you were at the workshop about regular expressions, that's another use for them. You can edit text or numbers in the cells of your table. So regardless of the format that your initial data file was in, you will see it as a table here, okay? And you can also export your data as a spreadsheet. Oh, and naturally import it here as well. So when we imported this data, we had, remember that screenshot I had with a CSV format. The first column was just names, right? And it was interpreted here as the ID column. The ID column is always the first in a lot of data structures. But we don't really have labels. And to be able to display labels on the nodes, when we go to the section later, we need a separate column for that. So what we are going to do now. So you can see that it automatically created a label column for nodes, right? But it's empty. So what we need to do is we need to copy the content of the ID column to the label column. And you do that by copy data to other column. Here you have to select the column from which you're copying. So ID. And then in the little dialog window, you will need to select the column to which you're copying. So it's label. Now we can click OK. And you can see that now this column is populated with the same names. Now, you can see that the names that have a name and the surname or house, I don't know how to properly name this in the context of the Game of Thrones, but they have this little hyphen between them. It's something that was done in pre-processing when they were extracting names from the text to treat these composite names that consist of two words as a single person, right? They had to connect them for it to be easier to extract. It's probably not very nice aesthetically when we think of displaying them on the graph, so we may want to get rid of these hyphens in the label column. We're going to use search replace for that. It works as a search replace function in any text editor. And we can search for hyphen and replace it with a white space. We can also use regular expression here if we like. And we can do it either in all columns or in a specific column. I want to leave IDs intact, so I want to do it in the label column. Okay, to define next, and then replace all. Okay, it should have done the job. Very hard to drag these windows. Come on. Okay, it's probably not draggable. Anyway, close. I'll just close it. Come on. Oh, it's just showing me a little report that 128 occurrences were placed on my other screen. Sorry. And that's why it didn't let me drag or close that window. Anyway, okay. Now it works. Yeah, you can see there are no more hyphens here. We can do close. And we can probably save a project at this stage just to be on the safe side. Again, there is a pop-up window. And it will save it in its own Gephi format. Let's save it on my desktop. And you can always go back to a project later and you will have all the changes you made, all the appearance adjustments you made to the graph. If you just reopen your saved project. Okay, so we did what we needed to do with the data. And now we can go back to the overview tab here on the top with our graph. So at the moment, it doesn't look very representative. It's all black. So what we want to do is to color it and maybe change the sizes of the nodes in the first place. Here on the right, you can see the statistics tab, and it has some of the metrics we discussed in the theoretical part. Average degree, average weighted degree, graph density, the clustering coefficient, a lot of things. And you can install plugins to that we will go to later to have more metrics. But the one that we need now is modularity. Remember, this is a metric that allows you to split the graph into communities. And that's what we want to do. We want to see which characters appear together in the text more than others. So how do they form communities in this particular book? So we need to click where's modularity? Run. And just click OK. It will give you a little report about the distribution and cite its sources for the algorithms, which is very nice. It does it for all metrics. Okay, so now when you go to this little appearance window, I can't even see from here. It lets you change the color and the size of the nodes and edges. So now they're all colored uniquely. That's what unique stands for, and they have the same color. You can color them by partition, and you can choose one of the metrics you have. We have the modularity class. So when we ran this algorithm, it split our network into several communities. And now every node has an assigned modularity class or a community label. And we can color the nodes according to it. Or we can color the nodes according to their ranking. For example, degree, how many connections they have. Let's go with the partition. So we want nodes belonging to different groups, different communities. They color differently. And now you have this palette. Luckily, we have 8 classes, and all the default palettes have 8 colors in them. But sometimes it can happen that you have more communities than that, and you want to have more colors. You want to have a unique color for each of the communities. You can generate your own palette by going here, generate, and if you just uncheck the box limit number of colors, and it will just generate a palette of as many values as you have. We're just lucky that in our case it's 8, and default palettes already have 8 colors. But if you had, say, 40 here, if you uncheck this box, it would generate a palette of 40 different colors for you. And there are different presets for palettes. Oh, you won't actually see it before you click generate. Okay. So you can choose according to your taste, but we don't need that. We have a default palette, it's fine. And to apply that, we click apply. And you can see that the graph has changed. Let's see, where is the... Sorry, you can't see the screen from there. Zoom in. Where's the there? Okay. It's very strange that it's displayed like that. It's also easier when you have a mouse than a touchpad. So the touchpad is quite hard to control these graphs. If you lost your graph, this button with the magnifying glass recenters the graph. Okay, so now they are colored, our nodes are colored according to the communities that were calculated using this modularity algorithm. That's not all we can do. We can also change the size of the nodes, and you have the next little icon here after the palette with the circles, and it is responsible for the node size. And again, you can size them all uniquely, or you can size them by ranking. And here, let's choose degree. So we'll make the nodes that have more connections bigger and the nodes that have fewer connections smaller, right? So we can also set the range of sizes. These are just very arbitrary measure units. So you can just try different numbers here to see which work better. It'll go from 10 to 100. And then you have to click apply again. Okay. Now you can see that the nodes that are bigger, well, you can't see it yet, but you can see that some nodes are bigger and some nodes are smaller. But it's still, it looks nicer than it did, but it's still not very representative. To make it easier to read, easier to interpret, we can use a so-called layout algorithm. So at the moment, nodes are placed on the canvas at random. There is no meaning to where a node is on the canvas and no meaning of the distance between different nodes. But we can run a layout algorithm that will make the distance and the position of the node meaningful. There are a number of different algorithms. They're all in this little layout window on the left here. So one of the two most popular algorithms for small world graphs are the Force Atlas and its updated version, Force Atlas 2. It was developed by people who developed Gephi. And another one is Futterman-Reingold. It's also quite good. They're both force-based, so they calculate the forces that attract those together. But we're not going to go into detail, so let's just give it a try. And yeah, by the way, in the lecture notes, you'll have a brief description of every algorithm and a link to Gephi's own tutorial on layout algorithms, if you want to understand them better, if you want to dig into the math behind it. Okay, so let's try the Futterman-Reingold first. So you select the layout algorithm and then click run. And you can see that something starts going on. So some algorithms stop themselves and some algorithms don't. If you think that your network looks fine, actually, it's weird. Again, that this hover behavior is activated. It shouldn't be. By default, you should see the whole graph, but okay. If you're happy with how your network looks like, you can just click stop. And if you don't have the stop button for some algorithms, you can just click cancel. It won't revert any layout changes. It will just stop it as well. So we can just click stop. And you can see that trying to really see. Come on. It just doesn't change the settings, although I'll ask it to. Anyway, so if you zoom into, you can see that some nodes got closer to each other, often nodes that are colored in the same way, which is exactly the behavior we expect because we colored the nodes according to the communities they belong to, right? So they should have more connections within the community than with the rest of the graph. So they should be close together. Let's have a look at another algorithm called Force Atlas. Yeah, I'll do the Force Atlas 2. It's just a newer version and it's optimized. It runs faster, but it's basically the same. Yeah, this is a little bug, I'd say, in Gephi because it should have a stop button because it doesn't stop automatically, but it doesn't because I ran another algorithm and stopped it before it. So I'll have to do it with cancel here. So yeah, you can see that something happened. The nodes regrouped, but they're too close together for you to see. So if you think that the nodes are too close together, you can run the expansion algorithm that will pull them apart. And you can click run as many times as you like before the look of that graph satisfies you. So as I said, Force Atlas is very good for small world networks, and you can really see how nodes that belong to same community are attracted to each other. Okay, so probably can run expansion even more to see more. Okay, that's much better than what we started with. But naturally, I think we want to know what these nodes stand for. And we created labels for that. To enable labels, there is this little toolbar at the bottom, and there is a big T letter. So if you click this T letter, it will show you the labels. You can control the size of them and the transparency of the edges here. So that's the transparency of the edges, and that's the size of the labels. You can choose font, you can choose color. Then you can see that some labels are on top of each other, which is not ideal for readability. So there is another algorithm in the layout menu that deals with this, and it's called label adjust. If you run it, it will rearrange the graph in a way that labels are not on top of each other. By the way, there is another algorithm like this, but for the nodes called node overlap. Where is it? Overlap. So if you think nodes overlap each other and you don't like it, you can use this algorithm. Okay. Any questions so far? Yeah, let me just go back. So that's the second icon here with the circles. So you click this, then nodes should be selected. Then you choose ranking and degree. And then click apply. Did it work? No, it shouldn't be affected. Like the appearance and layout are independent. Are you working with the same data or with your own? Let me just have a look. Oh, it's just the size, accent size. Not defined or very small. It's very small, so you don't really see the difference. Yeah, yeah, something like that. Yeah, no, yeah, it is very important when you are changing the size of the nodes, there is a span you can put on it. So the minimum size and the maximum size in some arbitrary measure. So to see the difference, you have to make the span quite big, say from 10 to 100. Otherwise, you will not see the difference. It depends on your network. So it's better to experiment and see which looks best. Okay, probably a good time to save our project, right? Not to not to lose anything. And yeah, you can do it just by Control S as in any other software. Now, we've been working with Overview tab and the Data Laboratory tab. And there is a third tab called Preview. So Overview is mostly for like designing your graph and working with the metrics and analyzing that, but it doesn't give you a very nice picture to export and to put in your research paper or on your website. That's what the Preview tab is for. It gives you a much nicer rendering of your graph. Oh no. In it. Okay, my touchpad isn't very responsive, I'm afraid. Okay. Okay, so there is this third tab here called Preview. You go there. You may see nothing at first. To see your graph, you have to click Refresh. Looks very nice, much nicer than the one in the Overview tab. But there are a few things that are not carried over from the Overview tab. So you have to enable labels again, and because the thing in the backend that is drawing your graph is a different thing, to put it very simply, the graph can appear denser than it was. So you may want to go back to the Overview tab and run expansion algorithm again. That's a bit annoying, but that's how it works. So it looks more or less fine here. Expansion. It's showing one working area over another. Maybe it has to do with the screen size. Anyway, and if you do that, you go back, click refresh, and see that the nodes are a bit further apart, more readable. Okay, now to enable labels, there is a working panel on the left, and there are different sections, nodes, node labels, edges label. So to enable labels, you check this box, show labels. You can also change the font here. It's independent from the Overview tab. If you change the font here, it won't change in the Preview tab. You have to do it again. Fortunately, you can limit the length of the label to make it more readable. And you can change the outline. And then to see the changes, you have to run refresh again. So now you can see the names. Okay, and you can control a few other things here about appearance, say the transparency of the edges. Probably you don't want them to be like solid as nodes. You want them to be slightly transparent, and you can control it. I think it's, yeah, sorry, you can see. Yeah, thickness of the edges. So this, sorry, it's not transparency, it's thickness. So you can scale them down a little bit. But there are also like opacity, it's transparency, I suppose, settings in the nodes and node labels. So a lot of controls over the appearance of the graph. Let's just change this, scale down the, come on. Scale down the thickness of the edges a bit. By default, it's 1. And it's calculated automatically. So the stronger the connection is, the more it appears, the thicker it is. But we just want to scale it down to 0.5 maybe. Refresh. And you can see that the edges are not as thick now and they don't actually cover the nodes. We want to do maybe a bit more expansion on this. Go back to overview, run expansion a few more times. Go back to preview, refresh. Okay, more readable now. Still there, you may want to change the transparency of the nodes or where or if the labels are on top of the nodes. I won't do it now because I can't really see my big screen from where I am, but there are settings for that. When you are happy with your graph, you can export it, and there are different ways to do that. You can export it as a static image, as a picture, by clicking this little button, Export SVG, PDF, or PNG, or by going to File Export. It will do the same. So if you need a very small picture, you can go with PNG, but if you want it to be a scalable graphic where people can zoom in and see all the details, you'd better export it in PDF or in SVG. So for adding to a paper, PNG for to a printed paper. PNG is the best option to for adding to a website or just publish it as a standalone piece of research. It better export it in PDF or SVG if you want it to be a part of the website. But this is not all. You can also export a dynamic visualization of your graph and host it somewhere like GitHub. And we're going to try and do it now. So, are there any questions up to that point?
That's pretty, there's a cluster up there on
Yeah.
the screen now. Is it possible? But a lot of that thread going up there, the links going up there are actually just long and pretty empty. Is it possible to compress that, just that portion of the graph on its own?
Yeah, that's a very good question. If you go back to the overview tab, you can drag nodes to where you like them to be. Yeah. So basically, like, they're not lost. They will be in the image, but yeah, you're right that it's not the handiest way to display it. So you can go back to the overview. This, I don't know why the working area behaves so strange here. The screen. So normally that's the working area of the overview. And you can just click on the node and drag it. So if something is far away, you can just select it and drag closer to where you would like it to be. So yeah. Any other questions? Let me check the chat. Okay, no questions in the chat. So let's go to dynamic visualization export. Again, a good idea is to save the project, because to export a dynamic visualization, we'll need to install a plugin. And after installing the plugin, Gephi will restart. So not to lose all the work we've done, we'll have to save that. Okay, just by Control S. Now, to install plugins, you can go to the Tool menu on the top, Plugins. There are some that are installed by default. Here you will see the list of updates if there are any, and there's a tab called Available Plugins. As I said, some of them are just different metrics, different layout algorithms. And there is one called Sigma Exporter. I actually have it installed, so it's not in this list for me, but I'll show you the name. It's not an ordered, alphabetically ordered list, which doesn't help. Sigma exporter. Okay, it's on the top. That's what the plugin is called. So when you find it in the available plugins list, just check it and click install. There will be a button. So if you check something here, you call install and then follow the installation instructions, accept everything, let Gephi restart, and then reopen the project. So this plugin is basically a JavaScript plugin that creates a little website, one-page website from your graph data, and it's dynamic, so you can select different nodes, you can perform search. It's very handy, and you can host this kind of websites on GitHub for free. You just let me know when you're done. Did it work for you? Okay. Is it after restart or?
That's installing somehow. After I hit the install button, that happened. And it only took 10 minutes to start.
Oh my God.
From Gephi. I don't know what's going on with my computer.
The same thing happened to me, and then I restarted the laptop. I got my problem.
Okay. Did it help? No? Okay. Oh my God. It used to cause a lot of issues in the previous versions, but since I upgraded to the last one, it was working pretty smoothly for me. But maybe it depends on the computer as well.
The issue with some programs too is that it's a pretty new, very expensive university computer. But I think it's because it has everything on one drive. For some normally simple things that just takes ages. then when I was at the IT service, they just said, yeah, update the system and we don't know.
Yeah.
Restart now.
Yeah, anyway, all these steps are described in the lecture notes, so even if it doesn't work for you now, you can probably follow later and try to try to get it working. Yeah, I don't actually know what's the language in which Gephi is written. Somehow suspect it might be Java by the behavior. Anyway. Okay, let's just wait like 3 more minutes and then continue. Does everyone have an account on GitHub? GitHub. Okay, while this is restarting for some of you, I'll show how to create an account on GitHub. I was planning to do a seminar on GitHub and Git in general as the first one in the series, but then something changed because of the other presenters' availability. So it's now the last one in the series. So if you want to know more about it, there will be a seminar on Git, GitHub, version control, and a bit of the command line basics in the end of May. But okay, let me show you how to create an account. If I'm able to drag my window to the right screen. Okay, so let me just sign out. So you go to this website called github.com. It's basically a code repository, but you can use it for your research materials as well. It's free, and it's very good for collaboration. I signed out. Why didn't you sign me out? Okay. If you go to github.com, it just remembers me. Okay, sign out. Yeah. You can click sign up. It will ask for an email. Then you'll need to create a password and a username. And then it's pretty straightforward. You just follow the account creation process. It might ask you to set up a two-factor authentication. And then after you do, your own little repository address will be github.com/your username. And if you are planning to use digital methods in your research, GitHub is a very useful thing to have to share your research and to collaborate, even if it's not very code heavy. Okay, I'll just sign back into my account. Okay. Is it still restarting? Your Gephi? Okay, let's create a repository then.
Find me, I will just.
Okay. Do you manage to create an account on GitHub? Or are you still in the process? Okay. Who's just registering with GitHub? Okay. Okay, I'll just show how to create a repository for people online, and we'll go back to that later again. So to create a new repository, you can think of it as a folder for your project. You just click Create New Repository. You select a name for it. There can be no white spaces. If it has a few words in the name, they have to be connected either with dashes or underscores, or it just has to be all one word. You can add a short description. You can choose visibility, whether it's public or whether it's private. You can add a README file. This is basically just a text description. I'd advise to just check this box by default. And add a description later if you like. And there are also options to choose licensing, but that's not something we're going to work with now. We'll go into more detail about all these things in the workshop about GitHub. So yeah, all you need is just repository name, then just make it public or private, whatever you like, add a README file. Let's just call it test because it's a little later. And then you just click create. You will have this basic interface that you can interact with from your computer or with a graphic interface on the website. And what we will need to do later today is upload files. Just click add file upload, and then you will be just able to drag a folder or a file from your computer here. But we'll go back here later. Okay, let's go back to Gephi. So how do we export a dynamic visualization? When you install the plugin, if you go to File, Export, trying to see where I am. I also have a university laptop, which can be a bit annoying and slow. Yeah. And you go to File, Export. You will have this Sigma.js template. You'll need to click this. When you click this, you'll have a little dialog box where you can add a description for your future interactive visualization. So here, the path is the path where a folder with the files for your dynamic visualization will be saved. You can move it later. It doesn't matter. It's just a path to save the folder. Then you can add a legend. So what are your nodes? I have mine pre-filled because I did an export already to write lecture notes. Yours will be empty if you're doing it for the first time. So you can write down what your node is, what your edge is, what does the color stand for. this will be a little legend on the map on this website with a graph. You can add a link to your university logo, a link to something else, say your personal website. You can add your name as an author and the title of the graph. Right? Then you can check the box to include search. This will work as just a normal text search across the labels. Then if you have a directed graph, you can group the edges by direction. Then you can select the behavior on hover. When you put your mouse, hover your mouse over a node, you can either deem the rest or do nothing. Then there is a thing called group selector, where you can select a whole group of nodes. There will be different options here. Can color, ID, label, interval, modularity class. Honestly, the only thing that makes sense here is modularity class, because we haven't really calculated anything else, or we didn't have any other attributes in the source data. Color is basically the same as modularity class for us, because that's how we colored the nodes. Yeah, and then image attribute. Don't really remember what it is, but there must be documentation. Anyway, you can add a short description and a longer description for your graph, and then click OK. When you do that, you see that the export is completed. You will have a folder called Network in the location you selected. Again, let me just drag it here. I select the desktop. Here's my folder called Network. And in this folder, you have CSS files, images, JavaScript files, config.json. If you forgot to add something to that description in that window, you can always edit the config.json file. That's where all of it is. Then the HTML page itself, README, and web configs. Apart from config, if you don't know JavaScript or HTML, don't touch any other files. If you do, you can tweak the appearance of this visualization even more. Okay, now what we do is we need to put this folder, or rather not the folder itself, but the contents of the folder, to our GitHub repository. So I'll just drag it back to a different screen. Open GitHub. So you have this, I'll go through this again. Maybe cancel. So you created your repository, you are within it, you click add file, upload files, and then you can just drag whatever you need to upload in there. Yeah, all the files from the network folder. Will do its magic, list all the files you uploaded, and that's not the end. You have to commit your changes to record it in the journal of the actions you do. It's an essential part of version control. Just click commit changes for it to actually happen. Okay. Now the files are uploaded, they're in your repository on the server, and you have all the same files, okay, with your network. But that's not the end of it. They're there as source code, but you need to create a web page from it. To do that, you just go to settings. Basically, you can create a web page from any GitHub repository. You go to settings and go to pages and see the section branch. GitHub pages is currently disabled. So you need to enable it and you have to select the branch from which you want to deploy your website. Again, we will talk about it at the seminar on version control, but basically your repository can have different versions, different for different purposes. There will also always be the main one and some, say, development branch where you test some new features before making them permanent, before pushing them to main. Or you can have a separate branch for a website. So ideally, you should have a separate branch for it, but just because it's not the topic and some of you may not have dealt with GitHub before, we'll just choose main here and click save. But ideally, it should be a different branch. Okay, just for demonstration. Okay, now if you click save, you can refresh the page. And you should have, where is it? Applying. You should have a little box here saying your website is hosted at this address. It's strange that it's not doing this. Right? Should be done. Yeah, here it is. Just took a little bit of time. So when the website is deployed, you will see the address where your website or your dynamic visualization in our case is. You can just click here and you'll see your graph. You can drag it as you like. You can zoom in and yeah, you'll have the labels if you zoom in close enough. Again, the distance may look a bit different from what you saw in the preview tab, just because, again, the visualization is created with a different backend in this case when you export it. But it will be pretty much like what you see in the preview tab. And there are different selectors. So if you, we selected dim for the hover behavior. So when you hover over a node, everything except its connections is dimmed. I'll zoom out a bit. Yeah, you can see better here. Right, that's on hover behavior. Then when you select a node and click on it, you will see all its connections and the class, the group it belongs to. In our case, it's just a number, but in the data laboratory, you can actually label the classes. If you interpret them and see, oh, these are meaningful, these are, I don't know, characters that follow Daenerys or something like that, you can rename the modularity class and have something meaningful there instead of a label, instead of a number. And you have all these connections here ordered alphabetically and can click on any of them. Touchpad is awful, and see their connection, so you can navigate the graph and you can return to the full network. Here you can see that legend that we created when we were filling in this window with a description, a short description, the legend, what a node is, what a link or connection is, and what colors mean. And then the search. Text search. Did I type snow? Can't see. Probably Probably made a typo because there should be 2 characters shown. I don't know, it's probably just slow. Ideally, you should see just all the matches here, and then the top match will automatically be displayed here if you click enter. Anyway, that's the dynamic visualization you get, and that you can share with anyone, and like it's free to host indefinitely, which is great. And you can change the license. You can add your university or lab logo here. So that's quite a powerful instrument. Okay, and that's all I have for today. I know that some of you had troubles with Gephi or maybe GitHub, but you will find all the steps covered in the lecture notes with screenshots, so you can refollow them and try to make it work. Are there any questions?
Very beginning.
Yep.
There was a choice between, on the one hand, new project or open the graph file, I think. Those are the 2 choices. And you went with open graph file for fairly old students. Now, with new project, would that be would you be inputting raw data there, or is it so that would be starting data from scratch?
Yeah. You can go with create a new project. It is a good choice if you want to input raw data within Gephi, but it doesn't stop you from importing data. You can just start a new project and then click import and import your data. So it's just a different route to it. And yeah, actually, I remembered something that I wanted to show you, but almost forgot. If you go to import settings, you can actually append a different data file to your existing data. So these are only the database on the first book in the series, but we have 5 of them, right? If we want to build a graph based on all the books, and the data happens to be separated into 5 files, we can just append them. If I find my cursor, I'll show you how to do it. So we can go to either import or data laboratory. Let's go with import for a change. Wait, where's the open window? The third. Okay, that must have been changed. Okay, let's go to data laboratory and click import spreadsheet here. Okay, now it works as expected. You have the file opening window again. So you can choose a different file. I have book 1, I can have book 2 here. Click open. And basically the steps will be the same until this window, where I can choose, instead of creating a new workspace for this data, I can append it to my existing workspace. So now, if you just scroll down, you can see that new data has been appended to the table. It doesn't have labels, and it hasn't been processed. So, oh, it's not. Yeah, you can't really see it here, so you'll have to trust me. You'll just have 2 graphs here, and one will be shown in the same way as the first one before we did any changes to the appearance. So it will be just black, all nodes the same size. So you'll have to redo all the appearance changes again. So my advice, if you want to collect some data, you better import all of them first. Do all the changes on all of them, say add in the label, populate in the label column, replace in the hyphens, and then work on appearance. But it's not impossible to add some data later. You just have to rerun some of the appearance settings. Yep. It is, yeah, you can merge the 2 data files in a different program. It's easy to do with CSV, but say if you have a GXF file or GraphML file, it may be tricky to merge them yourself somewhere. So it's easier just to import them separately into Gephi, and it will do all the merging for you. And then if you want to save them as a single file, you can export table, and it will export all the data that you imported from different sources as a single file. And in the same way, if you created some data within Gephi, you can export it in different graph files or in CSV. Okay, any other questions?
Just to follow up on that, you suggest that it might be a good idea to import all 5 books once and then do the next.
Yeah.
Now, point is, supposing you really wanted to, just as a first step, just to analyze book 1.
Yeah.
If you, but later on you may go on to the others. Supposing you've imported all 5, labeled them, can you now home in on book 1 alone?
You can. You won't be able to see book 1 alone in this settings, but you can, for example, color or size nodes according to which book they appear in, if this is in the metadata, if you have this labeled. But in the same way, if you want to analyze all the books separately, you can just import the second book in a new workspace, and it will be a different graph. The questions? Yeah. Yeah. Yeah, there are lecture notes. Let me show them to you. And it is all there. Where is my Firefox? Oh, okay. I hate this thing. Okay, I'll close the graph because I can't access here. You'll have the link to this repository with, these are all the workshops data, by the way. For Gephi, you'll have the link to this. And there is a file called Network Analysis MD. These are the lecture notes, basically all we went through in the slides and in the hands-on session is here, just as a long text with pictures. So all of the steps is how you work with Gephi are described here and accompanied by screenshots. The Sigma export is there as well, somewhere in the end. Yeah, dynamic. Yeah, I'm just afraid I have to run after the workshop somewhere else. But if it doesn't work for you, you can always email me and I'll try to solve it. Yeah. No, absolutely not. Yeah, labels are just unique identifiers to distinguish between nodes. And it just happens that when you import data from a table, the first column is interpreted as IDs. And that's how our names ended up there. Labels are always what is shown on the graph as names of the nodes. Yeah, most often, and when you export, say, when you export them to Sigma, it replaces the text IDs with numeric IDs because that's how it usually is done. Usually IDs are just numbers. So yeah, you have freedom there. Yeah, please. It depends on your data. It depends on your data. So this graph, it doesn't have any this data doesn't have any information about the direction of connections. So that's why it is undirected. But for example, imagine someone created a graph based on the same data, but based not on the co-occurrence, but of which character speaks to which character. So in this case, one would be active and would be the source of the connection, and the character that is spoken to will be addressee or like the end of this link. And in this case, this is a directed graph. So it depends on your data, and you can't import an undirected graph as a directed one. There's just no data for that. But you can import a directed graph as an either undirected graph if you think the directions are not important for your particular visualization or research.
Just make up things. Yeah. So what is actually happening then?
It can probably be a bit slower. The most important thing that the size of your data can affect is the layout algorithm. So some algorithm can be very slow, or may not converge well with a lot of data. So let me just go back to overview. So the standard ones like Force Atlas work good enough up to 10,000 nodes. But there are other algorithms, like there's one called Gephi here somewhere. Yeah, Gephi proportional. This is a very fast algorithm, and it can work with networks of up to 100,000 nodes, I think. Yeah. Yep. Any other questions?
Okay.
Please, yeah, please.
The weight?
Huh?
The weight.
Wait, yeah, let's go back to data laboratory. So here we only have degree, so basically the number of connections each node has. But sometimes you can have a column with, say, if you're studying a transport network, you can have a column with travel times between stations or bus stops, and you can use this as weight for edges or something. Because here we don't even have it as a separate column, right? Degree is calculated by the number of connections a node has. So it doesn't even have to be a separate column in this case. But yeah, I don't know if it answers your question.
Yeah. Is that
Oh, in the visualization, yeah, if you choose, there is a tick box somewhere, I think in the preview tab, where you can choose if the labels are proportional to the node size or not. If they're proportional, it's the same, yeah. So whatever attribute you choose to size the nodes, it will be the same with labels. If you untick this box, the labels will be just of the same size.
Is that necessary? Is that affected the outcomes at the end? Or not? So we can just put ID labels and that's it?
Yeah, that's the minimum, because you will have a ranking, like the degree, you will have it anyway, because if you import nodes and their connections, you can calculate the number of connections. The program will do that for you, and you can use it for weighting. Whether you want to use any other metric, any other data for weighting is up to you. But yeah, the minimum you have to import is just nodes and connections between them. That's it. Okay, cool. All right, yeah, I hope it was useful. The recording will be on YouTube, and I will send you a follow-up email as always. If you want to know more about creating the data and like link data, that is a very close topic to network analysis, can register for the next workshop, which is in April on the 24th, I think. And yeah, if you have any questions after, you can always email me. Okay, thank you. Okay, I'll stop the recording now.